In topic 4, and we are skipping section 3 of chapter 6, we're going to do rational equations. So these are equations that contain fractions. And in this section, again, we're showing you the technique of what to do to get answers. So, with that in mind, let's get set up. So, there aren't too many of these, so I'll do them in great detail, which I think we've been doing that. So you're going to write them out. So we will use some of the techniques we already had. And again, there's different ways to do it, but I'll show you what I like. First of all, to get rid of the fractions, we have to find our common denominator. What will our common denominator be here? And it's 2x. So the rule is we're going to modify this equation now by making it an equivalent equation, but without fractions. So we do so by multiplying each term by our common denominator, 2x. Now here, I'm going to cancel out the x, and I get 18. Here, there's nothing to cancel out, so it's a negative 3 times 2x is a negative 6x. Now nicely here, the 2x cancels with the 2x, and I get a 3. So look at this equation, and now look at this. So much easier. You've multiplied every term by the lowest common denominator and canceled out all of the denominators. They're all now 1. So I like to have a positive x value, so I'll switch that to this side, becomes 6x. I'm going to subtract that from this side, and I get 15. I'm going to divide both sides by 6, and I get x, and I can cancel, take a 3 out, 5 halves. And if you were to put 5 halves theoretically in there, that would check. And I checked it, and that was the answer. Now, for this one, notice it's a fraction equals a fraction. So for this, we could use a modified way of doing it just by cross multiplying. This is going to become 5 times 2x plus 3 equals 12 times x minus 3. So this becomes a 10x plus 15 equals 12x minus 36. This will be, I'm going to move the 10x's to this side. So this becomes 2x, and this becomes a 51. And now I divide both sides by 2, and I get x equals 51 halves, which I believe is correct. So again, a technique Whenever there's just a fraction equaling just a fraction, you can cross multiply like so. Okay, let's set up letter C now. I'm going to raise it up a little bit too to see if we can see the answers. That'll be nice here. Nope, still can't see them, but that's all right. They're down there. So let me write this out. Now, as we look at this, and we sometimes forget that a negative 3 is over 1. What's our common denominator here? 8g. So I'm going to multiply every term by 8g. Remember, this is part of how equations are solved. So, nicely, this cancels out. Here, the g cancels out. And the 4 will go into there once. And we're left with a 2 here. Here, a 2 goes into there once. And we're left with a 4. And here, we already have a 1, so we're good. Now, we don't have fractions anymore, but we have to multiply through. So this will be 2 minus 34 equals, now 4g times g is 4g squared, and I better take that 1 out of there so we don't get confused. And this is going to be a negative 24g. Now this, when we do our subtraction, will become a negative 32. And we have this. So I'm going to bring this negative 32 over to this side now. And this then becomes a positive 32 over there. And with the magic of an eraser, this now equals 0. So what do we have here? We have a quadratic equation. And how do we solve quadratic equations? Well, we put it in standard form, equal it to 0. But notice we can take out a common factor here of 4 to make this a little easier. We're also dividing 0 by 4. So this still stays 0. This becomes g squared minus 6g plus 8. That's a little easier to factor. Now we factor this. G, 4, 2, minus, minus. So we then get G will equal a positive 2, or G equals a positive 4. I just cut out a step there. Just transpose these. And there's where I get my answers. Now, we have to keep in mind, too, that anytime we get rational equations of this type, we have to ensure that an answer that we get doesn't make our denominator a 0. So here, a 2 or a 4 doesn't make our denominator a 0. So these are both good answers. Now, as we look at example D here, I'm just copying it. Notice that this, when I factor x squared minus x, becomes this. And now this happens to be my lowest common denominator. Now, again, there are different techniques for doing this. I'm going to now multiply each of these. First of all, I'm going to make this a plus and make that a minus there. Okay. This is a technique we had earlier. Helps us keep our signs straight a little bit. So we're going to multiply every term by the lowest common denominator, which is x times x minus 1. X times x minus 1. And x times x minus 1. Now another way is to make a big bracket and just put this once out here. But by writing it by each term, I think maybe that might be useful. So we cancel that. This all cancels, which is nice. And then this cancels here. So now we get 6x minus 6. And here, because of our negative, and we put that in a parenthesis, this becomes a negative 8 plus 4x. We just change both of these signs, and this becomes 3x. So from a rather complex fraction, we ended up with something rather simple, I think. So we group like terms. This is going to be a 10x, and this is going to be a negative 14. And this is a 3x here. Okay. Well, to save time, I'm going to move the 10x to this side, and it becomes a negative 7x. And this becomes a negative 14. So going from this side to that side became a negative 10, and a positive 3x gives us this. Now, here we have to remember to divide by a negative 7, both sides. So we get x equals 2. And that checks. I looked down below already. So again, they get to be a little confusing, but picking out your common denominator, multiplying each term by your common denominator, and this little conversion of signs here, I think is useful. Combining like terms and watching the signs carefully. Okay, again, lots of algebra. So for our last one, and let's see if we can move it up a little bit to get to our answers yet. Oh, I guess we had a lot of room here. Here they're saying in function notation, it's basically just this. 2x minus 5 over x equals 3. Now they could have said that originally, but they want you to be exposed to function notation. This is a value that will be equal to this value. So what's our common denominator here? X. So this becomes 2x squared. Here the x's cancel out. We get a negative 5 equals 3x. Notice we have a quadratic equation. So to solve it, we have to put it in standard form. Transpose that. Now we need to factor. I believe our 5 is going to go there. So this is going to be negative and this will be positive. How about putting the right number there? Okay, so again, shortcut, this is equal to 0, this is equal to 0, so this is going to be 5/2. Transpose the 5, divide by 2, or x equals -1. And I've checked those, and those are correct. All right, well, this one was a little shorter. Remember, I do have additional exercises as a video in which I go through a lot more of these and showing different techniques. We also have the textbook, where I go through the textbook of each of these sections. And again, part of this, doing the practice, the quiz-mes, to earn your mastery. So when you take your modular test, you're going to do well.